Hello everyone and welcome to our last video lesson of Chapter 7. We're on 7.9, square root functions and inequalities. So before we dive into square root functions, let's remind ourselves what we know about this equation. First of all, it's it's x equals a y squared. So when it's y equals x squared, it's a parabola that goes like this. So if it's x equals a y squared, we know that it's a parabola that opens up to the side. So now in Chapter 6, we talked about this form, vertex form, x equals a times the quantity y minus k quantity squared plus h. So our vertex is at hk. So our vertex is at 2 and a positive 1. We know that it opens to the right because our a value is positive and it's a positive 1. So on our grid paper, it starts at 2, 1, and it's going to open up a little something like this. Okay? So now what we have for this lesson class is what were to happen if we were to solve this for y. So now we would have x minus 2, that equals y minus 1, the quantity squared. Now we would square root both sides. So we would get the square root of x minus 2 equals y minus 1. And then we would add 1. So y would equal the square root of x minus 2 plus 1. And whenever we square root something, we need both the plus and the minus. So if we were to put this into our calculator, here's the type of graph that we would see. Now for today's lesson, we're square root functions. So as you can see, it's the square root of x minus 2. What you should always remember, class, is that the square root, when it's just positive or only negative, it's half of a parabola. So we're going to be seeing functions that look more like this. It's half a parabola. Or if it's the negative sign, now we're looking at parabolas that look like this. So that's what we're seeing today. So let's see just a couple things that we notice about these first 5 graphs. Okay? So just take a minute, pause the video if you need to, and look at these graphs and just tell me a couple things that you notice. Hopefully here's the first thing that you notice is that they all open to the right. Okay? Let's back up a second. First of all, hopefully you notice that they all have a curve. They're not straight lines, they're not linear, they have curves. Second thing that you hopefully notice is that they all open up to the right. And here's the reason for that, class, is that this is a positive x. This is a positive x. This is a positive x underneath the radical. Positive x and a positive 2x. Whenever it's positive, it opens up to the right. We don't deal with any negative signs because those open up to the left. Okay, when it's a negative underneath the square root. Let's see if there's anything else that you notice. Did you guys notice where the vertex is? This vertex is 0, 0. This vertex is 0, 1. So as you can see, this 1 shifted it up 1 unit. This vertex is at left 4, down 2. So you take the opposite of this 4, negative 4, and you take what's written here, you go down 2. For this one, you go right 2 and up 3. Right 2, up 3. And for this one, it's a little bit different, but this one is also 0, 0. There's nothing written out here, so it's a positive 0. And we have our 0, 0 right there. Hopefully that was another thing that you noticed about the vertex. Final thing that I want you to notice before we dive on to the domain and the range is hopefully you saw that these 3 opened up and to the right. Oh, sorry. These 2 opened up and to the right. These 3 opened down and to the right. So what were the difference between those? If it opened up and to the right, the sign outside the radical was a positive sign. If it opened down and to the right, the sign in front of the radical was a negative sign. So those were hopefully 4 distinctions that you saw between those graphs. So all that knowledge is going to be very helpful for when we have to graph this on our own and using our graphing calculator. So now we're going to talk about the domain and the range. What is the domain and the range of all these graphs? Well, the domain is the x values, so we use a vertical line. So where do our x values start? They start right at 0. When x is 0, that's our first x value. So I always like to do interval notation first. So our interval notation, it starts at 0, and how far to the right does it go? This goes infinitely to the right. So it goes from 0 all the way to positive infinity. Now class, on all of these, it can equal the number that we start off at. So you don't have a parenthesis there. Because it can equal 0, you're going to start with a bracket. So 0 to positive infinity, you close that with a parenthesis. Infinity always has parentheses. So now for our set notation, this is where we say x such that x and y such that y. So x such that x, we tell in an inequality what it's greater than or less than. It's everything to the right of 0, so it's greater than 0. And like I said, it can always equal the number that we start at, so it's always greater than or equal to 0. There's our set notation. So now for our range uses a horizontal line. Where do my y values start? They don't start until we get right there, right at 0. So our y values also start at 0, and how far up does this blue line go? It goes up very, very slowly, but it will continue to go all the way to positive infinity. There's no limit to how high that goes. So it goes from 0 all the way to positive infinity. Once again, we're always going to have a bracket there and parenthesis after infinity, because it can equal 0. So for our range, y such that y, once again, is greater than or equal to 0. Let's try number 2 and see how that changes. It shifted up 1 unit. So it starts where this 1 is. So it starts at 1. Our domain, however, remains the same. The x-coordinate, this point right here, is at 0, 1. So my x-coordinate, it still starts at the x-coordinate of 0. That's where I start. So at 0, and then it goes all the way to positive infinity. This blue runs all the way to the right forever and ever and ever. So 0 bracket, parenthesis after infinity. So for my set notation, it's x such that x is everything greater than or equal to 0. So for my range now, my range is where it becomes a little bit different than the last one. Instead of starting at 0, it shifted up 1 unit. My first y value is that vertex, which is right there at 1. So my domain starts at 1. It can equal 1, so I put a bracket right there. And how far up does it go? It goes all the way to positive infinity. And I end that with a parenthesis. So my y such that y is everything greater than or equal to a positive 1. All right, you guys try number 3 on your own. Let me know what the domain and the range is. Pause the video, please, and try it on your own. For the domain, you should have gotten a -4, and it goes all the way to positive infinity. So remember, even though this graph goes down and to the right, my domain, my vertex here, starts at left 4, down 2. So it starts at a -4, and then it's everything to the right. So it goes from a -4 to positive infinity. We're going to have a bracket at a -4 and a parenthesis after infinity. So my set notation is x such that x is greater than or equal to a -4. Now hopefully you guys got the range right. The range is a little bit tricky just because it's different than the first two. The range starts down here at negative infinity. This blue arrow goes down forever and ever and ever. It goes down very slowly, but it does go down forever. So it starts at negative infinity, and then it stops right there at a -2. So we always start our range from bottom to top. So we start at negative infinity. That has a parenthesis, and it stops at a -2. So that's where our bracket is going to be. Negative infinity to a negative 2. So our set notation is y such that y, instead of everything greater than, it's everything less than or equal to a negative 2. It's lower than negative 2, it's below it, so we say it's less than or equal to. So hopefully you got that for your range. Let's try 2 more examples before you guys will become experts at this. Our vertex starts at right 2 up 3. So our first x-coordinate is a positive 2, and then it goes to positive infinity. So our domain starts at 2, and it runs until positive infinity. So for our set notation, x such that x is greater than or equal to a positive 2. Our range, it starts way down here at negative infinity again. This arrow goes down forever. So it starts at negative infinity, and where does it stop? It stops right there at a positive 3. So we're going to start at negative infinity, and we're going to end up at a positive 3. It can equal a positive 3, so we have a bracket there, and then with infinity, we always have our parentheses. So it goes from a negative infinity to 3. So for our range, for our set notation, is y such that y is less than or equal to a positive 3. And our last one, number 5. This one starts at 0, 0. So for our x-coordinate, we start at 0, and we go to positive infinity again. And for our range, or for our set notation, x such that x is greater than or equal to 0. Now for our range. Our range starts at negative infinity for the 3rd time in a row. And then it ends when it comes to the x-axis, which is the y-coordinate of 0. So it starts at negative infinity, and it ends at 0. So y such that y is less than or equal to 0. So those are a couple things that will certainly help us out when we start graphing these on our own coming up in this next video lesson.